So let's go ahead and do a few slides in this. Let's go ahead. So we can kind of now, you're like, well, that looks like a foggy day here in the Midwest, you know. But actually, that is in China. That's an example of them having issues with air pollution. Okay, so we're going to talk about something called air quality index. And actually, if you're in China, you probably keep track of that. When to go outside and when not to. Okay. Now, I'll kind of preface this chapter with the fact that at the end of the chapter, I kind of say there is good news, but I need to talk a lot about the bad news. Okay, now air pollutants are man-made, and air pollutants actually can be made by Mother Nature. But something is considered a pollutant if it's adverse to health. Okay. So, like I said, we have man-made pollutants. Now, clear back in Unit 1 when we talked about carbon dioxide in the atmosphere, I said that there were anthropogenic sources of carbon dioxide. Like if you're an anthropologist, you study people. So an anthropogenic means it's people-made. So, and then we have naturally occurring sources of things that are adverse to life. And I'll show you on the next slide coming up. Though the slide we saw a minute ago with China, it looked like kind of like fog, okay? It looked like haze. Haze is something that actually in fog would be an example of the type of haze. But something in the atmosphere that you can see, and the reason you can see anything is because it's interacting with light. So it's either light is either scattering off of it or light is being absorbed by it, which actually in the case of smog is probably a little bit of both. So speaking of smog, the term smog actually historically comes from smoke plus fog. Smog, smoke plus fog. I wonder who thought that one up. Okay. So here again, picking on China, city in China, that's an anthropogenic issue right there. But actually, you see the sun coming up, and the weather plays a part in whether we're going to have bad air quality or good air quality. So we'll kind of talk a little bit about that. So this top here is our anthropogenic sources. So we're going to spend a little bit of time talking about burning fossil fuels. So this one over here says combustion processes. That is the old proverbial burning fossil fuels. Okay. And I think I'll go ahead and up here on the board, I'll kind of say what happens when you burn a fossil fuel. Well, here in a minute we're going to watch a few little videos in this part. But of course, fossil fuels are oil, coal, gas. Okay, basically what happened was a long time ago, either a dinosaur, there's my dinosaur, okay, or a plant, here's my plant, okay. What these both have in common is that they're carbon-based life, so they have a lot of C for carbon, okay. So basically, they died, okay, and pressure and time basically turned them into oil, coal, and gas. So the chemical that we're most interested in burning is carbon and hydrogen. Now, if you're used to like H2O, you guys would say there's 2 hydrogens and 1 oxygen, H2O, right? Well, hydrocarbons, oil, coal, and gas, we don't know how many carbons. They could be long chains, or it could be short chains. It could be like 100, or it could be like 50. So I'm just going to put CXHY, because I don't know the formula for those hydrocarbons. Okay. So combustion processes, what they do is you light it in the presence of oxygen, put a G there. Basically, they burn, and the products over here are carbon dioxide, CO2, put a G for gas, and H2O, and I'll put a G for gas there. I guess I should put, well, I could put an S here, or an L here, or a G here for your hydrocarbon.
And that's a combustion reaction? Or?
Yeah, this is just a general formula of a combustion reaction. So this is your hydrocarbon. See Seems like a good name for it, hydrocarbon. This is your oil, gas. Okay. All right. We'll talk more about that. Other ways that, other anthropogenic sources of pollutants would be the nuclear energy. Okay, it has issues. Mining, quarrying, farming. Okay, but we'll spend a little bit of time talking about the burning of fossil fuels. So down here, these are all Mother Nature's issues of putting things in the atmosphere. Now, like the previous slide said, those things could be gases, those things could be solid particulates, aerosols, they could be liquid, okay, aerosols. Okay, it's just adverse to life. Now these actually, Mother Nature does them or has a major role in them. Wildfires, dust storms, bacteria and viruses, but it's kind of got the blue thing going, which means that, and a very good example coming up is the Dust Bowl, the Great Depression, where basically humans, with our interaction with the, I guess it'd be like the geosphere, because it was over farming, has a negative impact on what that does, what the Mother Nature does.
We still get dust storms down there.
Yes, you do.
Just as bad.
Yeah.
I mean, not just as bad, but it will cover your car with dirt.
I've heard that.
It's not fun.
Yeah. So this is a slide, Mother Nature doing her thing. Actually, this was, the forest fire was not made by some idiot, right? Starting the forest fire. It's actually made by lightning strike. So, and it's said, have you heard this too, that some burning of our forests is healthy. So.
Actually causes it to grow back better.
Yeah. But in terms of air pollution during the time of the event, the particulates, the smoke, the carbon dioxide is an issue. So, but yes.
Might store carbon dioxide.
Yeah. And then this one is, it's hard to see in there, but there's a volcano in there that is sending up emissions. And the caption here says basically, one of the things that volcano is sending up is sulfur dioxide, and the sulfur dioxide combines with oxygen and water vapor to actually make this haze. Okay, so instead of calling it smog, this is really clever. They call it VOG, which I had never heard this. VOG. So yeah, this goes back to what Cassie was talking about, the dust storm. This is not the Great Depression. This is back in 2013. This is just 3 years ago. Okay, showing you the dust rolling in. That would make me want to run for cover.
Oh, that's not that bad. I mean,
That looks bad.
well, the worst of it is usually during the dry months, dry season. So
Yeah.
unless it's like really windy, you really don't have to worry.
Yeah, and just this morning, I was looking for like California, their issues, and they actually put out wind warnings and
In southern
Like that.
Arizona too.
Southern Arizona
You're
too.
driving down the freeway and you see the cloud in front of you and you go, oh.
Drat. Looks like something on a science fiction show.
It's
I
just
don't
not
know. So actually, though, I have a video to kind of talk a little bit about this historically, not just confined to kind of where our dust probably is confined to now, but the Great Depression was like 8 years or a decade or so in the 1930s. So I think it ended in 38 or so, but let's take a look at the video. You know, the wind patterns are very natural, but man's over-farming in that case actually led to aggravated the conditions. Okay, so we're going to watch another little video. Now, I said that the end of this part has good news about air pollution, and you're going to see that obviously we've come a long way. But historic photos like this kind of show you what the conditions used to be like. This is in Pennsylvania. I doubt if Pennsylvania looks like this now. Okay, it used to be, honestly, that if your smokestacks were billowing soot, the more they billowed, that was thought to be a good thing because it means that you're prospering. So, yeah, take a look at this little video. else we got? I know it's also sad. So, with regard to anthropogenic sources of pollution, we have primary pollutants and we have secondary pollutants. So actually these are just generally primary pollutants. Now, carbon monoxide, the formula for carbon monoxide is CO. So actually, I have on the next slide that says, by the way, that is deadly to people. It doesn't take much carbon monoxide to kill you. That's like people who leave their car on in their homes, in their garages. I have a car now for the first time that has one of those where you push a button, you don't need the key. So cool. But those, I guess, they're kind of quiet, and some people don't turn off their car. They don't hear it, and so they can actually, carbon monoxide will kill you, I guess is my point. Carbon monoxide comes from what we call incomplete combustion. Incomplete combustion. If this is combustion, incomplete combustion will give you carbon monoxide. So anyway, about 61% of the emissions in 2012 were carbon monoxide. Then we have nitrogen oxides. I'll talk more about volatile organics coming up, sulfur dioxide, and particulates. So now those are, I think, kind of primary pollutants. Secondary pollutants then mean that you take a primary pollutant and usually it's a chemical reaction with the sun, for instance. Basically, something happens to these to form something else. Okay, so it's an emission, something happens to it to give you something secondarily, which takes something that's not toxic and makes it toxic, or takes something that was toxic and makes it even worse. So a secondary pollutant. So here's a list of primary pollutants, carbon monoxide, and these I kind of gleaned from the literature what sort of kind of fossil fuels, what sort of situation you get these pollutants in. So for instance, carbon monoxide, like I said, an incomplete combustion of fossil fuels. Lead, some of you guys probably are too young to know that usually you used to go to the gas station and get leaded and unleaded gasoline. So now it's all unleaded, okay? But the amount of, I can just put PB here. I don't know if lead was an additive into the gasoline, so your cars ran more smoothly, I want to think, maybe. I don't think it was in the source, but anyway, lead's an issue. Sulfur dioxide and sulfur trioxide, they come from burning fossil fuels on a large scale. And similarly, cars and power plants put out nitric oxide and the nitrogen dioxide. So now these two down here, if you want to put secondary pollutants, you can. So these are secondary. I'll put secondary. Oh my goodness. These are secondary pollutants. So photochemical smogs, there are kind of an assortment of them, but one of the things photochemical smogs can do is take something that was harmless, just simply hydrocarbons in their gaseous state, and you react them with light and you make this smog, photochemical smog. An example of a photochemical smog is ozone. So what's the formula for ozone, you guys?
O3.
O3, it is ozone, O3. So O3. We talked about good O3, good ozone. Where is it located?
Oh, what's it?
Where's the good ozone? Good ozone
It's in
layer.
the, stratosphere.
It is the stratosphere. Yep, very good. It's not the troposphere, it's the stratosphere. So good ozone, and there's a hole that occurs, we said, over the pole area in the spring, okay? But bad ozone is in the troposphere. And so, yep, bad ozone is in the troposphere. And it is a secondary pollutant, also involving the sun, who helps form this ozone. I like this figure. On the left, actually, these are energy sources, and on the right, these are things that use the energy. And so it's quite clever. So for instance, if we pick on petroleum up here, all of our this is, can't remember what year this is, 2012, yep. So of all of the sources of energy, this was about 36% came from petroleum. And of that, 72% went to transportation, 23% went to industrial, 5% went to residential, and 1% went to, you take petroleum to power to create electrical power. I guess that's kind of interesting. So looking at it another way, if we look at transportation here, 93% of our transportation is fueled by petroleum, 3% is fueled by natural gas, and 4% is renewable energy. We're hoping that green sector grows, aren't we? We want this one to get bigger. So that's kind of how that goes. Quite clever. So carbon monoxide is a pollutant just in and of itself. It's a primary pollutant. The redder it is here, the more carbon monoxide. And kind of the caption to go with this is, if carbon monoxide is an anthropogenic pollutant, if you're like me, you're like, well, where did this carbon monoxide come from? What do you think? How did that carbon monoxide get over the oceans?
The Gulf Streams.
Yeah, just the wind, just the air current, exactly. Yep. I've heard it put this way. It's like if you go swimming much and they have a section of the pool for you can urinate over here, but you can't urinate over there. I know that sounds really gross. But my point is, like, if you have a no pee zone and a pee zone for swimming, is that going to work?
No.
Why not?
Diffusion.
It's going to diffuse. It's all going to get mixed up. So that's kind of what we see here going on here. But the other thing, when I was looking at this, check this out. What do you think? What's the southern hemisphere? Do they have much carbon monoxide?
Because there's not as much population in
I would believe there's not as much industrial activity down there. Yeah, they're a little simpler. But remember, also the southern hemisphere, remember it's mostly water. I mean, they got more water down there. Okay. And the other thing, though, I thought was interesting is, what does ITCZ stand for? Yes, intertropical convergence zone, exactly. The intertropical convergence zone separates, and it wanders, but it separates the northern and the southern hemisphere. So that was kind of my thought here, just looking at a glance. It's like, well, maybe it's kind of like our air and their air. So we should all go to the southern hemisphere. So I don't know. It's a thought. Let's see. I'm kind of leaning towards. Yeah, let's do this one on particulates. Okay. So, I don't know why this sticks in my mind, but the whole asbestos thing, asbestos abatement and that sort of thing, the thing, as I understand it with asbestos, is it's a particulate issue. It's not like a toxin. It's not like you ingest it and it gets in your bloodstream. It basically plays havoc with your lungs. And so, honestly, if you have a particulate of a certain size that's floating around out there, it can be harmful to your lungs. So, we'll probably get through this chapter in Wednesday's lecture. In Wednesday's lecture, we'll talk about how the EPA actually has limits on particulates. So what they do with regard to particulates is they talk about the size in terms of, and we didn't do much with the metric system in here, okay? But that up there, of course, you recognize M is meter, right? M is meter. This symbol right here is micro, so these are micrometers or micrometers. Okay, so 0.1 to 100 micrometers. This is pretty small. So down here, how big is it kind of puts things into perspective with regard to human hair is 70 micrometers. Okay. This is kind of an interesting thing. With regard to particulates, remember when we talked about cloud condensation nuclei and we said don't drink, don't eat snow or whatever because it probably had some level of particulate to get the condensation process started. Well, particulates are good at, especially if they're high, water-loving, hygroscopic, okay? They can actually go ahead and make condensation happen when it's not even 100% relative humidity. So these particulates are noted for actually getting the party started, getting the condensation party started. What is condensed water suspended in the air? We call that fog. So we kind of have a particulate kind of going with the smog sort of thing. So yeah, this was my whole asbestos thing. Inhaling particulates of a certain size are definitely adverse to your health. Okay, well that's a good place to stop. And we'll pick up here, but I really think we'll get through this on Wednesday.